Today we are going to solve first bad version. This question has been asked in Google, Meta, Amazon, Microsoft, Apple, and this is one of the question that improves our understanding of binary search. Again, we are going to solve this using binary search as mentioned in the description also. The main motive is to identify when a question says that it can be solved through binary search. So let's go ahead and see the question. Question says you are a product manager and currently leading a team to develop a new product. Unfortunately, the latest version of your product fails the quality check. Since each version is developed based on a previous version, all versions after a bad version are also bad. Suppose you have n versions, say from 1 to n, and you want to find out the first bad version which causes all the following ones to be bad. So you want to find the first bad version. You are given an API is bad version which will be able to tell you if the version is bad or not. Implement a function to find the first bad version. You should minimize the number of calls to the API. Okay, so there are two hints here. Hint number one is it says that once a version fails the quality check, once the version fails the quality check, all versions after it are also bad, are also bad, are also bad, and all the version before it will be good, will be good. Right. Second hint is you should minimize the number of calls to the API, so that you should not call this API for each version maybe, for each version maybe. Right. So one linear approach would be to check for all versions linearly and to solve it in O of n time. But this would result in O of n time, meaning that for n numbers you will call the is bad version, I mean at least the is bad version n times if the last version is bad version, right? Okay, so thinking about the question, it says n version. So let's say example here. So the example given in the question is something like this. You are given n and it says that the bad version is at 4. So this is given. It's a pretty I would say not a good way to represent it, because mostly people will think that is it a input. But if you see the solution, you will see that the method accepts only one input, right? So that is n, and this is like a given, like the fourth version is bad here, right? So this is basically the answer they have given. Okay, so you can't just return bad because you don't have access to it. Sorry to break your hopes, but you can't just return bad. You'll have to iterate through the versions and find the first bad version. Okay, so like I said, right, it says that suppose three versions are good and fourth version it is bad. It, you can see the answer space over here, it is monotonic. Basically the good increases and the bad increases. It's not like good bad good bad good bad, right? If you have watched the previous video like coco eating banana, or the second one that I did, you will see that I have focused on the observation where if the array is sorted, maybe you can use the binary search, or if the answer space shows a monotonic behavior, then also you can use a binary search approach. Okay, but how do you use a binary search approach here? How do you use a binary search approach here, right? So let's say the versions are 1 2 3 4 5, right? Binary search says that you can place left here, right here, and middle here, and do the binary search pattern, right? Do the binary search algorithm. So here also you will notice that here the answer was bad version is this, right? So I have the media measure, so this is the good version. So what does it mean? If this version is good, can I say that all the version that are on the left side are also good? Yes, yes, that is the that is given in the question, and all the right side could be good or bad. So where should I move? Should I move left or should I move right? I should move right, correct? Because the bad version, potential bad version, is on the right side. Okay, so what is the second space that we form? So what we will do is we will move left to +1, right? So left equal to middle plus 1 हो जाएगा, middle plus 1, and the answer space will become 3, 4 and 5. Sorry, 4 and 5, 4 and 5, right? Not 3, 4 and 5, 4 and 5. Okay, now you have all the bad versions here, right? So again, left and right would be this, middle would be this. Okay, so this time you will see that this is the first bad version, and since you want to find the minimum valid answer, right, minimum valid value for an answer, because B could be the first one, the leftmost one, so you want to return left, you want to return left, you want to return left. Okay, okay. So another example to show here for this algorithm is, another example to show here for the algorithm is when n is equal to 9, when n is equal to 9, right? So the version would be 1 2 3 4 5 6 7 8 9. Now we know that the question says that this is the bad version, right? And these are the good versions. So I'll place 2 pointers again here and here. The mid would be somewhere here, right? So now I am at this position, I have 4 here, 4 here, I am at this position. This is a bad one. So do I know that all the left ones are good? No, I don't know, because this could be the bad one, or this could be the good one or the bad one, but this could be the first bad version also, this could be the first bad version also. So like I did for left mid plus 1, I cannot do right equal to mid minus 1, because this could be a bad version, the first bad version again, right? So at this point I'll do a right as mid, that's it, I do a right as mid. So now this would be the space, again I will check, so this would be the thing. So I can see this is a good, so all the left are good basically. So I can I can ignore this one and I can start from this space. So the next space would be 4 and 5, 4 and 5. Again the mid would be 4, again the mid would be 4. This is a bad version, this is a bad version, this is a bad version. I already know that these are the good versions, these are the bad versions. So I'll move just this ahead, I'll basically I'll have this, so I'll return left, I will return left. Okay, so observation here was very clear. You want to find the monotonic behavior in the answer space. If you can see a monotonic behavior in the answer space, then it's a clear-cut hint that you can use binary search. A clear-cut hint that you can use binary search. Going back to the solution is very simple. Your left has to be less than right. Your mid is left plus right minus left by 2. If it is a bad version, right, if it is a bad version, we don't know if the previous one is bad or not, so we just do right equal to mid, right equal to mid. And if it is a good version, that we know that all the left ones including this one is a good version, so we just have to search the right space, so it was left plus, mid plus 1, left, right, left becomes mid plus 1, and we just want to then return the answer. Going to the observation here, we just want to look for a monotonic answer space. If the question wants a minimum valid value, which is in this case yes, so we can return left, so this is how you analyze that you want to return left or right. If it is asking for a maximum valid value, then you will have to return right, okay, that's it for today. Thank you.